today we are going to cover 8.6, which is solving rational equations. So what I want to have you write down at the tippy top here, an equation has an equal sign. Expressions do not. Up to this point, we have only been simplifying expressions. We've simplified them, we've multiplied them, we've divided them, we've added and subtracted rational expressions, but we have not solved them up to this point. So it's really, really important now that we're going to throw solving in is you need to look for an equation. So I put these steps here, and I want you to keep reading and rereading the steps as we go through all the notes and as you do your homework tonight. Because by the time you're done doing all of that, you should have the checklist stuck in your head. But if you never look at the notes, then you might struggle with doing this, okay? So step 1, if possible, factor each denominator. Okay, so let's look at example 1. There's no factoring. Step 2, determine the LCD and any restrictions. And I put in parentheses, that's where the denominator would be equal to 0. So in example 1, what is the LCD? 15. Okay. Any restrictions? Is there any value for x that would make those two denominators 0? No, because if I have 3 and 6, it's not 18. It's the least common denominator. Okay, so you don't necessarily just multiply them, but that does happen a lot. All right, so Grace, you want to help me? Okay, if I plug -3 in for x. No, I'm talking about in the bottom. Okay, restrictions are what makes the bottom 0. If I plug in 0, does that make the 3 become a 0? If I plug in 0, does that make the 5 become a 0? Daria, what do you think? No, if I plug in 3, that doesn't make the 3 become a 0. Nope, somebody already said. -3 doesn't make the denominator 0. Let's go back. What is a restriction? A restriction is that's where the denominator would be 0. How can you make 3 become 0? There's no x in the bottom, so you can't put 0 down in the bottom, right? It's a 3. You can't put anything in it other than the 5 down in the bottom. So no matter what I'm plugging in for x, that's not going to change those two denominators. Why not? Why doesn't 0, 3, -3? Why don't those make those denominators 0? This is what I need you guys to be thinking about. Ideas?
Is it possible to have no restrictions?
It is possible to have no restrictions. And because 3 never becomes anything other than 3. 5 doesn't become anything other than 5. You guys, when we say where the denominator would be equal to 0, there is no x in the bottom. You get that? There's no x down there. All right, so again, step 1, factor the denominators if it will. These didn't. Step 2, determine the LCD, which we got, and there's no restrictions. Step 3, I want you to underline this. Multiply both sides of the equation by the LCD. What that's going to do for us is it's going to clear the fractions. So here we go. I'm going to take, and I want you to write it down, and I'm going to pause a moment to make sure you have it written down. When we say multiply both sides of the equation, that means everything on the left side. Oh no. I'm going to get it off. So you multiply everything on the left by the LCD and everything on the right by the LCD. So now what I want you to notice is on the left side, that 15 is technically 15 over 1. Okay, when you multiply by 15, that's not 15 over 15, it's 15 over 1. Now, this is a beautiful connection to 8.4. This is multiplication. What we learned is 3 goes into 15 5 times. 5 times 2x is 10x. Now, it'd be over 1, but I don't need that. The purpose is to clear the fractions. So when I multiply by 15 to a fraction, I want to make it 15 over 1. So 5 goes into 15 3 times. 3 times x is 3x. Now, I don't want to make 15 over 1 on the right side because that was a whole number, okay? So I'm just going to do 15 times 13, which I already did, and that's 195. Step 4, solve the resulting equation. This is an Algebra 1 level equation. It's an equation with one variable. So I get 13x equals 195. Divide by 13, and you get 15. Step 5, check your solutions against the restrictions. There are no restrictions, so then I'm going to circle this as my final answer. All right, we're going to go through the steps again, okay? Step 1, if possible, factor each denominator. There's no factoring. Step 2, determine the LCD. So I look at all 3 denominators, 4x, x squared, 2x squared. Who feels confident about the LCD? What do you think it might be? Yeah, so you did? 4? We've got a 4. Oh. And then what about the variables, though? X squared. Okay, if they both have an x, you take the higher power, so it's x squared. Now, the restriction, you take the LCD and set it equal to 0. Well, then x can't be 0. So here we go. I'm going to take 4x squared, so step 3, multiply everything by the LCD. The purpose is to clear the fractions. When you solve an equation, we do not build common denominators. Let me repeat that. When we are solving equations, we do not build common denominators. We're clearing the denominators. So I'm going to change these since they're all times a fraction. I'm going to make my 4x squareds over 1. All right, then let's see what kind of reducing we can do. 4 goes into 4 evenly, x goes into x squared 1 time. So that's going to leave me with 7x. In the next product, my x squared cancels, and I have 4 times 3, so that's 12. My x squared cancels, 2 goes into 4 twice. So I get 7x minus 12 equals 2. Add 12 to both sides. I get 7x equals 14. X equals 2. Check it against your restrictions. X can't be 0, so x equals 2 is a good answer. All All right, let's try the next one. Step 1, I finally get to factor a denominator. X squared minus 9 factors into x plus 3 times x minus 3. All right, what is the LCD here? X plus 3 times x minus 3. My restrictions are where the LCD equals 0. So x cannot equal plus or minus 3. If you put a minus 1, yeah.
Plus 3 and minus 3.
Yeah, that's okay. All right, so here's kind of the tricky part. When you go to do step 3 and you multiply everything by the LCD, that's a lot to write down. And I'm going to show you on the next one. I don't know that we're ready for it yet, but you can do that mentally. And I want to put this factor. Don't leave it x squared minus 9. So step 1, if possible, factor each denominator. So I had a denominator that I could factor, the x squared minus 9. Step 2, determine the LCD. It's x plus 3 times x minus 3. You find the LCD by taking each unique factor. If a factor appears more than once and they don't have the same exponent, you take the higher exponent. To find the restrictions, you take the LCD, set it equal to 0. Step 3, multiply both sides of the equation by the LCD because we want it to clear the fractions. Now, go back, when you take that LCD times a fraction, go back and make it over 1. All right, now I'm multiplying, so I'm trying to cancel. So an x plus 3 cancels, and I get 5 times the x minus 3. Here, both denominators cancel, and that leaves me with just 2. And on the right side of the equation, the x minus 3 cancels, and I have 4 times x plus 3. I'm going to pause, and I want you to solve this resulting equation. You guys, whenever you are absent, try to get onto Schoology that day and watch the video and try to keep yourself caught up. I'm getting 5x minus 15 plus 2 equals 4x plus 12. That's 5x minus 13 equals 4x plus 12. If I subtract 4x from both sides and add 13, I get x is 25. Last step, check it against your restrictions, and I get x equals 25. All right, questions on that one?
You got an answer and it was like your restriction, would it be no solution?
Yes, beautiful. Great question. Okay, she said, what happens if, like, say it worked out to be x equals 3, and that's a restriction? You cross it out, say no solution. All right. Example 4. I have 3 over x minus 3 plus 7 over x plus 3 equals 2 over x squared minus 9. I'm going to pause if you haven't already started, and I want you to read through the checklist and do as much of it as you can on your own. Yeah, you do end up with a fraction on this one, which is okay. So my LCD is x plus 3, x minus 3. So x cannot be plus or minus 3. Now on this one, I want to show you a technique. If you can go with me, go. If you're like, whoa, I can't figure that out, then don't do it that way. I'm going to multiply by the LCD mentally. So I'm going to imagine in my mind that I'm multiplying by both of those factors. The x minus 3 cancels, and that would leave me with the 3 times x plus 3. Then I would need to multiply by the LCD. The x plus 3 cancels. That's 7 times x minus 3. On the right side, both factors cancel and leave me with just 2. Do you see that's a whole lot less to write down? If you can go with me, go with me. If you're like, whoa, I can't handle that, then you're going to have to do that big step of multiplying everything by the LCD. Yeah.
How did you do the last part again?
This side?
Yeah.
I multiplied it by the LCD. So the x plus 3 cancels and the x minus 3 cancels. The entire denominator cancels. So I only have a 2 there. So this is 3x plus 9 plus 7x minus 21 equals 2. So I get 10x equals 14. And that's going to reduce to 7 over 5. When I check it against my restrictions, it's okay. And it's okay to get fractions as an answer. Wait, what? Yeah, 14 over 10 reduces to 7 over 5. All right, let's look at example 5 together. Step 1, factor any denominators where possible. So x squared minus 6x plus 8 is going to factor into x minus 4 times x minus 2. That happens to be the 2 factors in my denominators. So it's the LCD, x minus 4 times x minus 2. So x cannot be 4 or 2. Now let's see if you can go with me on this one. If I mentally multiply by the LCD, I'm not cross-multiplying, guys. Even though it looks like that, I am not. That's not what I'm doing. I'm taking everything times the LCD. So that x minus 2 would cancel, and I'd have x minus 4. I'd have a 1 times x minus 2. Okay, I am multiplying all 3 terms by the LCD. This is going to give me x squared minus 4x plus x minus 2 on the left side. I'm going to combine like terms and get x squared minus 3x, and let's go ahead and bring the 4 over. What kind of equation is this that has x squared in it? Quadratic. How do we solve quadratic equations? Factoring. Factoring should be your number one strategy. If it doesn't factor, what's the backup plan? Quadratic formula. Good job. All right, so x squared minus 3x minus 4 equals 0. I'm looking for two numbers that multiply to negative 4 but add to negative 3. Yeah. Negative 4 and positive 1. If you can read it off, I get x is 4 or x is negative 1. Uh-oh. Yes, I've got an extraneous solution happening here with x equals 4. So I cross that one out, and it's only x equals negative 1. All right, I'm going to pause, and I want you guys to try example 6. Try and get as far as you can on your own. I'm sorry, what? Yeah, look at the restrictions. I'm going to be returning some papers here, one of which are your corrections. The corrections were intended to help your grades, and they did not do that for most of you. I'm going to give you one more chance. I'm going to give you your scores. You need a new sheet of paper and do the ones that I marked X. You need to do them correctly. Like, the purpose of corrections is for you to learn what you did wrong, what you didn't understand. So I'm going to pass these back. Do a clean sheet of paper. And if you are not happy with the score you got, I'll let you do one more time, but I need it by Thursday. We have no school Friday. So I put a check mark if it was correct. I put an X if it was incorrect. Again, so on these corrections, if you are happy with your score, you do not have to redo it.
So we only have to redo the one that we got wrong.
Correct. Yes, you only have to redo the ones that you missed. You don't redo the ones you already got right. I'm not done returning them, but I want to go ahead and work on this. So my LCD is x minus 3, x minus 4. So x can't be 3 or 4. I'm going to do this one mentally. That's x times x minus 3 equals 15 times x minus 4 minus 2x. I am mentally multiplying everything by the LCD. I am not cross-multiplying. That is not what I'm doing. This is x squared minus 3x equals 15x minus 60 minus 2x. I get x squared minus 3x equals 13x minus 60. When I notice that it's an x squared, that's a tip-off that is quadratic, and I'm going to try to get everything on one side equal to 0. That's what we did back in chapter 4. So this one factors pretty easily. X minus 6, x minus 10. I check it against my restrictions. All right, let's flip it over, and I want to get to example 7 today, and then we'll do the rest tomorrow. It really is just the same. All right, flip it over when you're ready. And I want to do example 7 with you. When I have 4 over x plus 2 plus 3 equals 3x over x minus 3. What is the denominator of this 3? 1. So my LCD is still x plus 2 times x minus 3. So x can't be negative 2 or 3. So this one's going to be tricky. Tricky. When I mentally multiply by this LCD, that's 4 times x minus 3 plus. Now, nothing cancels on the 3. So you still have to multiply it by x plus 2x minus 3. I did not say you multiply fractions by the LCD. I said you multiply everything on the left, everything on the right. And then that'll be 3x times x plus 2. I want to make sure that you're hearing and understanding me clearly. You have to multiply everything by that LCD. If there is no denominator on one of the terms, that means nothing canceled. So, oh my goodness, what are we going to do here? That's 4x minus 12 plus. You cannot multiply 3 things. You can only, so if I had 3 times 4 times 5, I don't take 4 times, or 3 times 4 and 3 times 5. That's not the distributive property. So I'm going to first FOIL. I can only multiply 2 things at once. Okay, there is no such property that says 3 times x plus 2 and 3 times x minus 3. You multiplied by 9 then, not 3. So this is 4x minus 12 plus 3x squared minus 3x minus 18. So then you can begin to appreciate some algebra 1. Do you remember when you did 3 times x plus 2 times x minus 3 in algebra 1 and you wondered, why were we doing that? Well, here it's in rational equations. Now I'm going to collect like terms and get 3x squared plus x minus 30 equals 3x squared plus 6x. What happens to 3x squared? They cancel. Good. Now I'm going to subtract x from both sides and get negative 30 equals 6x. Dividing by 6, x is negative 5. I check that against my restrictions, and x equals negative 5 is absolutely fine. Yeah.